Good afternoon, everyone.
Morning, ma'am.
Sorry, good morning, everyone. Shall we start with our class?
Yes, ma'am.
Yes, ma'am.
Okay, fine. In the last class, we had seen that how the Nyquist plot is divided into sections. How do we divide sections? I hope everyone has understood till this point. Okay, so you have understood how to divide the different sections. Now, after dividing the sections, what we have to do, we have to map these sections in F-plane. It can be achieved by drawing the polar plots for various sections using shortcut method. Let us take one example and understand how it is done. Okay. For each, just quickly I'll tell you the procedure, then we'll take one example. For each section, you will see the starting point and the ending point. You will find the value of omega. Substitute to get magnitude and phase of gj omega at g omega at omega is equals to infinity and omega is equals to omega 1 plus. Get the rotation of plot and then rotation of starting point. Rotate the starting point through angle of rotation to reach the terminating point. This gives mapping of section 1 in F-plane. Similarly, we will do mapping of each section. We'll just find out the starting point and the terminating point and the angle of rotation, like how we used to do for polar plots. And we will plot for each section. Using the same procedure, we'll plot for each section. After mapping all the sections, we'll get a closed plot, which is your Nyquist plot. Now count the number of encirclements of -1 plus j0 and check whether we set the equation n is equal to minus p is satisfied. If the equation is satisfied, the system is absolutely stable. If the equation is not satisfied, the system is unstable. Analysis of last section in every case can be ignored as it does not affect the encirclements of -1 plus j0. Keeping this in mind, let us solve first problem. All of you please take down this problem. Done? Have you all taken down? Okay, we'll start. So first step is you will find the value of capital P. Now capital P is the number of poles lying on the right side of the S-plane. You see that the number of poles here, S is 0, S is equals to -2, S is equals to -10. So none of the poles are lying in the right half of the S-plane. One is at origin, other two is in the left hand side. So the value of capital P is 0 here. Now step 2. What is capital N? Capital N, you remember capital N? The number of encirclements, right? So the critical point -1 plus j0 should not get encircled by the Nyquist plot. Why? Because the value of n is 0. That means there is 0 encirclements. Or you can say the critical point -1 plus j0 should not get encircled by the Nyquist plot. Okay? Is that clear till this point? Say yes or no. Everyone? Am I audible? Okay, is that clear, everyone? Yes. Okay, fine. So pole, now the next step is you have to find the pole because you have a pole at origin. So I told you whenever you have a pole at origin or imaginary axis, you need to follow this method. Nyquist path, you need to draw Nyquist path. Now how will you draw Nyquist path? So you have a pole at origin, right? So you will be taking 2 points which are very close to origin. One is plus j0, other is minus j0, and you will draw a semicircle whose radius tends to 0, right? But you have poles at infinity also, so you will be drawing a bigger semicircle which covers the entire right half of the S-plane, and that radius of this is tends to infinity, and this is your Nyquist plot. Fine. So you will divide this plot in various sections. Section 1 is from plus j infinity to plus j0. Section 2 is plus j0 to minus j0. Section 3 is minus j0 to minus j infinity. And section 4 is plus j infinity to minus j infinity. Okay? Is that clear, everyone? This infinity path we always draw because we assume that Nyquist path covers the entire right half of the S-plane. If any point is present in the right half of the S-plane, then we say that the system is unstable. Is that clear? You will have to respond, otherwise there is no point. Everyone, have you understood? Chandra Mohan, Harshita?
Yes, ma'am.
Okay, fine. Now, after doing till this point, the next step is you will write down your transfer function. So your transfer function is k upon s into s plus 2 into s plus 10. You have to convert this transfer function in frequency domain. So substitute s is equal to j omega, 2 plus j omega into 10 plus j omega. Find out the magnitude of it. So you see the magnitude is k upon omega into under root 4 plus omega square into 100 plus omega square, right? Then you have to find the phase angle of it. Phase angle, how will you find? Tan inverse imaginary part by real part upon tan inverse omega by 0 into tan inverse omega by 2 into tan inverse omega by 10. Bring the denominator part at the numerator since this is 0 and substitute minus sign. So you get minus 90 degree for tan inverse infinity minus tan inverse omega by 2 minus tan inverse omega by 10. Now, for each after finding magnitude and phase of the given transfer function, you have to start plotting your Nyquist plot from section 1. Okay, so now section 1 is, can you tell me section 1, what is the starting point and ending point? The starting point is plus j infinity and the terminating point is plus j0. You need to know only this much information, starting point and the terminating point. So plus j infinity plus j0. Alright, so your starting point is plus j infinity and the terminating point is plus j0. That means your omega is infinity and omega is 0. So your omega starts from infinity and ends at 0. So you can find the magnitude and phase by substituting the value of omega in above two equations, magnitude and phase equation. You will get the value of magnitude and phase here. You see that your magnitude is 0, whereas phase is minus 70 degree. Your plot starts at 0, that means origin, at an angle of minus 270 degree. It terminates at again origin, but it takes at an angle of plus 90 degree. And when you find the angle of rotation, you see it takes 180 degree anti-clockwise rotation. So how will you plot it? Your plot starts from s is equals to 0 at origin, right? And it terminates at s is equals to plus j0, right? Listen to me carefully. It terminates at s is equals to plus j0. That means here. You have identified two different magnitudes, okay, at starting point and terminating point. Now, what is the angle? The angle of starting point is minus 270 degree. It starts at minus 270 degree. Now you see that the minus 270 degree axis and plus 90 degree axis are same, right? So it starts at this axis. It takes anti-clockwise rotation of 180 degree. That means this side rotation of 90 degree, again rotation of 180 degree, and it terminates at s is equals to plus j0. Is that clear, everyone? The magnitude is 0. Starting point is origin at s is equals to plus j infinity. It takes anti-clockwise rotation of 90 degree and then one more 90 degree, that is 180 degree, and terminates at s is equals to plus j0. Clear? This the direction of arrows also you have to plot. Just let me know, is that clear, everyone? This one. Yes or no? This is too much. You people are not responding only.
Yes,
Let me
ma'am.
finish like that only. Then what is the problem? Now section 2. Section 2 you see that it starts from plus j0 and terminates at minus j0. That means section 2 starts at plus j0, terminates at minus j0. That means the value of omega is plus 0 and minus 0. Substitute these value of omega in above two equations to get the magnitude and phase angle. So you got your starting point is at infinity minus 90 degree. Ending point is at again at infinity plus 90 degree. And when you find the angle of rotation, it is 180 degree in anti-clockwise direction. This is using polar plot, which we have already discussed. So all of you can do this, right? So how will you plot your section 2? So your section 2 starting point is plus j0. That means where is the plus j0? Yes. Ending point is minus j0. That means you have identified 2 points. It starts from here, it ends here. but it takes an anti-clockwise rotation of 180 degrees. So this is 90-degree rotation, 90 plus more 90-degree rotation. So this is 180-degree rotation. Direction of arrow you have to specify. So starting point is here, 90-degree plus 90-degree, 180-degree anti-clockwise rotation. Ending point is here, and this is your section 2. And the point where it touches right half of the S-plane real axis, that is your infinity. It covers the entire right half of it. This is your section 2. Clear? There is no problem. Here also you can draw a semicircle. No issues at all. Alright, you can draw a semicircle like this. Not exactly a circle, but yeah, like this. A shape like this. No issues. Now section 3. Now what is section 3? You see that section 3 starts from minus j0, terminates at minus j infinity, which is similar to section 1, plus j infinity plus j0. But here it is minus j0 minus j infinity. You can say that section 3 is mirror image of section 1. No need to work, no need to find magnitude and plot of it. Just you can draw the mirror image of section 1 for section 3 based upon the starting and terminating points. Right? Section 3 is mirror image of section 1 about real axis. So how will you draw mirror image of section 1 about real axis? Here. The direction of arrow will be opposite. Like this, and the direction of arrow will be opposite. Why? Because starting point is this and terminating point is, that's all. As I told you that the last point will be ignored in all the questions because it does not affect your Nyquist plot. So section 4th is an origin, so you can just ignore it. So step 5, after finding this, what you have to do is you have to find the point where your Nyquist plot touches your left half of S-plane. This intersection point you have to find. You know this point, you know this is infinity, you know this point, but you don't know this point where your Nyquist plot intersects with your negative real axis. Now, how will you find this point? You will rationalize the given transfer function. How to rationalize the given transfer function? K upon j omega into 10 plus j omega into 2 plus j omega. You have to multiply and divide this by conjugate of this denominator. So what is the conjugate of this denominator? Minus j omega into 10 minus j omega into 2 minus j omega. So multiply and divide this by minus j omega into 10 minus j omega into 2 minus j omega. Solve it, you get minus, assuming that denominator is represented by capital D. So you solve it, you will get this function, right? So this is real and imaginary part. Your equation can be split into real and imaginary part. What you have to do is you have to equate your imaginary part to 0. So this is your imaginary part. You have to equate your imaginary part to 0 to find the value of omega, right? This is your omega PC. Substitute this value of omega in real part, which is minus 12k omega square by d, where d is omega square into 4 plus omega square into 100 plus omega square. Substituting the value of omega found by equating imaginary part to 0 into real part, we get a value of point q, which is minus k by 240. This point q is the point where your Nyquist plot intersects with your negative real axis. You can just write the value of point q minus k upon 240. If the value of k is given to you in the question, you can get the exact value of this point, and then you can find out whether this point encircles minus 1 plus j0 or not. Is that clear?
Yes, ma'am.
Fine. Then for this particular question, you can go for next step. Otherwise, you can just, from the plot, you can see if your n is equals to minus p, how many times this Nyquist plot is encircling this point. It should satisfy n is equals to minus p. If it is satisfying, the system is stable. Otherwise, it is unstable. But for this particular question, you have to find the value of k. How will you find the value of k? For absolute stability, n is 0 for this question, right? So it should be located on the left side of point Q. That means your Q should be less than 1. And just find out the value of k will be between 0 to 240 for stability. If the value of k is between 0 to 240, the system is absolutely stable, not equal to 240. Equal to 240 means 240 by 240, it will become minus 1. We don't want the point to become minus 1 for the system to be stable. For the system to be stable, Nyquist plot should not encircle this point. That means the value of k should be between 0 to 240. That's all. Problem number 2 we will be discussing in next class. Today we have second class. That's all. We'll complete our portions today. If you practice these 2 questions, it is more than enough for Nyquist. Do you have any doubt? Do you have any doubt?
No, ma'am.
All of you should draw this plot and upload in Google Classroom. Also, those who have not submitted assignment 2, submit it by today. Already your marks will be deducted, but rather than getting 0, you'll get some marks. If you have any issues with any other doubts, you can ask me.
Graph.
Can you tell me the question? What is the doubt?
Graph, ma'am. Now only you shown that one.
Yes, tell me.
Here it should be S equal upwards, ma'am. Here it should be plus J0, no, ma'am.
Yeah, I'll change this and upload this, right? This should be plus
Yes,
and this should be minus. By mistake, I think I have done. Let me check in
yes,
section
ma'am.
that graph. Yeah, plus J0 minus J0. Okay, I'll change this and then upload my notes in PDF. Form in Google Class.
Yes, ma'am.
Any other doubt? Have you understood? Tell me frankly, have you understood this? Yes or no? You have to respond, right? Tell me yes or no. Ankit,
Understood, ma'am.
understood? If you want, in second arc, I'll repeat this question once again. Okay?
Okay, ma'am.
try to do by yourself. Okay. With this, we'll end our session. Thank you.